Hello, everybody. My name is Michael Buenas for short, and I'm going to give a presentation for my final task in my project-based internship, which would be the Home Credit Scorecard model for Home Credit Indonesia. Okay, so this would be the background for the presentation. Home Credit currently uses a variety of statistical and machine learning methods to predict credit scores. Now they are asking me to unlock the full potential of their data. By doing so, they can ensure that customers with repayment capacity are not rejected when applying for loans, and that loans are provided with principal, maturity, and repayment calendars that motivate customers to succeed. Evaluation will be conducted by assessing my analytical understanding. Also, please note that I will need to use at least two machine learning models, one of which is logistic regression. So for the other model within this project, I will be using gradient boosting. So these would be the installation requirements, the libraries that you can find within the requirements.txt file, um, including Flask, Pandas, NumPy, scikit-learn, imbalanced-learn, matplotlib, seaborn, and joblib. So now let's see the Microsoft Visual Studio code. Okay, so this would be the notebook one, which is the Jupyter notebook file. Um, so here you load the data first, which would use the pandas library. And then also in here, as you can see, so this notebook one is all about data pre-processing. And that's why you can see here that there are data cleaning functions, and then there's also data understanding. Hold on. Yes, and also it aggregates auxiliary data merged with main application data. There's also EDA and visualization, income credit analysis. And then once that's all finished, it's going to be saved in process train.csv and process test.csv. This is to ease the machine learning process that will be executed in Notebook 2 IPYNB, which would be another Jupyter Notebook file. So here are the results after I run the application, which I will further explain within the presentation. So according to the result, there are 307,511 um, loan applicants, loan applications within the training set with 122 features, while the testing set has 48,744 applications with 121 features, in which the target column is non-existent. The important finding here is that there's only 8.07% loan applicants that fail to pay, in which the target equals to 1, while 91.93% has successfully paid their debt. So there's also the target variable distribution graph, which shows inequality that is sharp between two groups, in which there are 282,000 non-defaulter, in which the target equals to 0, and 25,000 defaulter, in which the target equals 1. There's also top 10 features that are being correlated with the target, in which I used days credit mean, days birth, days credit minimum, and end date fact minimum, and JP date fact mean. All right. There's also the income versus credit amount by target scatter plot, which visualizes that there is no clear division between the loan applicants that failed to pay and no non-loan applicants based on income and credit amount. There's also high density within the lower left corner, in which most applicants have income and credit amount that is average, that is medium. There are a few outliers with income or credit amount that are high. Okay, so now we are going to move on to the notebook to IPYNB. So heads up, and I'm giving an advice here. It is best to execute this program not within your local environment if your PC GPU isn't that high, and to execute this in Google Colabs, because this is processing a very huge amount of data. So because I cannot execute this in a Jupyter notebook, and my Google Drive is almost full, I execute it in a Python file. Yes, in which the result is presented through a PNG file for each one. As you can see here, for logistic regression, you can see it through LR underscore feature underscore importance dot PNG. And for gradient boosting, you can see the graph through GB underscore feature underscore importance dot PNG. Furthermore, that there are also safe models which come with .pkl and also a submission CSV. So I'm going to explain about the results in the presentation. So for the AUC score interpretation, for logistic regression, there's 0.835 accuracy, which would be 83.5% level of accuracy, which is good, but the gradient boosting AUC is 0.973, which is 97.3% level of accuracy, which is excellent. It's amazing. So AUC would be the area beneath the ROC curve, which I am going to represent later. It measures how well the model differentiates between violator and non-violator, right? In which 0.5, the lowest score, would be just a random guess. So here would be the example graphs. So the business implication behind this would be that gradient boosting model is very effective within identifying potential debtors that would fail to pay. And this has the potential of decreasing credit jam by 97%, while still while still maintaining a degree of agreement that is appropriate. Okay, so these would be the features that come with each machine learning model, in which within logistic regression, there's this one, phone, employed, family members, goods, price, credit, there's phone, work city, children, document, and source. So this would be the ROC curve analysis, right? So this one, the blue line would be for gradient boosting, and the red line would be for logistic regression, while the scatter line would represent a random guess. So as you can see here, yes, it has a very high level of accuracy compared to a random guess. Um, the gradient boosting line, the blue line, sharply increases to reach a positive ratio that is correct, that is high, with false positive on the minimum. While the logistic regression, the red line, shows good performance, but is not as impressive as gradient boosting. Okay, so now we're getting to business recommendation. So gradient boosting is definitely preferable in making a main decision because of its high level of accuracy. While logistic regression is useful for ease in explanation when you need to give justification to a decision in front of board of directors. And then there's also risk management implementation, which is needed. For example, like there needs to be more analysis in terms of phone verification and employment stability, family size, and external credit scores. If there's any business impacts that are expected, that would be reducing defaults, increasing approvals, and generating better prices. So the next steps, if I am to advance from internship position to full-time employee, I'm going to update this program, this repository, so that it can validate on holdout data and then deploy with monitoring and creating a feedback loop. Mm-mm-mm. So this would be the dashboard in which I'm going to give a direct presentation. So in order to run this, you need to run this with Python app.py. So unlike a normal PHP based website, you cannot just run this directly into localhost. You need to run this Python app.py within the terminal, and then the website would look something akin to this. This would be the scorecard, in which, this would be gradient boosting, and this one would be logistic regression. So that has been my presentation. I want to thank everyone at Home Credit Indonesia for giving me a chance to create this project and add a new entry to my portfolio. And I hope my position can be leveraged into the talent pool. I know that my execution is a bit different because I'm not using Excel to display the scorecard. Instead, I'm using Flask, which would be more web-based, but I think that using Flask instead of Excel would be much better in terms of scalability. All right. Once again, thank you, and um, toodles.